Welcome to the first class of this four-part series on interactive media art using light and sensors. I'm your instructor, Mirabelle Jones, and I'll be introducing you to the Circuit Playground Microcontroller, a powerful device loaded with onboard sensors, LEDs, even a speaker. We'll also be using servos to make projects with moving parts. Let's get started. We're going to be using the Circuit Playground Microcontroller in this class, but what is a microcontroller? A microcontroller is an electronic device which is capable of doing one or more tasks. It is made for embedded systems and is often used in automatic control systems. It consists of memory, I/O ports, and a processor. A microcontroller unit usually comes with a breakout board which might extend its capabilities. Here are some popular microcontroller units. There's the Teensy, the ESP32, a Pro Micro, and on the left we have the Arduino Uno, which is often just called an Arduino. We're going to be using the Circuit Playground Express, which is a newer microcontroller loaded up with goodies for us to play with. The Circuit Playground Express has 10 NeoPixels already on board. It has a temperature sensor, it has a light sensor, it has a speaker, a microphone, a slide switch, 2 buttons, and it also has capacitive touchpads, which we'll be using today. Let's get set up. First, you'll want to install the Arduino IDE. To do so, you can go to arduino.cc, and under Software, you'll see a download link. You'll want to download the correct version, whether you're on Mac or PC. Once you're at the Arduino homepage, you'll want to go to Software, and then go down to Downloads. You'll also see that there's an Arduino web editor, but we're going to download the Arduino IDE. If you scroll down, you'll see that the latest version of Arduino is 1.8.13. To the right, you'll see different installers. Select the installer for your operating system. I'm going to select Mac. Arduino is open source software. You can contribute to its development here, or you can just click Just Download. You'll be prompted to save the file. Click OK. Once the file is finished downloading, you'll want to open it up. It should automatically expand. If you're on Windows, you're going to also want to install the Circuit Playground driver. You can find it at the following URL. Just follow through with what it says to do, and you'll be all right. This requires a special driver. You're going to want to go to the Adafruit website to find this. You can also just Google Windows driver Adafruit Circuit Playground Express, and it should be the first option that comes up. Once you're on the page that says Windows Driver Installation, you'll see a big green button that says Download Latest Adafruit Windows Driver Installer. Click this in order to download and run the installer. Then follow the instructions. Now we're going to want to install the library. In Arduino, we're going to go to Tools, Manage Libraries. In Library Manager, type Circuit Playground Express into the search bar. Then click Install on Adafruit Circuit Playground Express. Now we want to install the library. You're going to want to go up to Tools, Manage Libraries, and then you'll have the Library Manager pop up. We can type in Circuit Playground, and the Adafruit Circuit Playground library will pop up. Unlike the boards, there's just one library, so you only need to worry about installing the Adafruit Circuit Playground library for both the Adafruit Circuit Playground board and also the Adafruit Circuit Playground Express. To install it, select the version that's most recent, then click Install. Now we're going to install the board. In Arduino, you're going to want to go back to Tools, and then under Boards Manager, which is under Board, you're going to type in Circuit Playground Express into the search bar. You can also type in SAMD boards if you don't see it. Be careful because there's actually two versions of the Circuit Playground. There's a Circuit Playground and a Circuit Playground Express. And we want to install the Circuit Playground Express, which is under SAMD boards. Once that comes up, click Install to install the latest version. To make sure that you have the right board installed, you want to go to Tools, Board, Boards Manager. Here you should type in SAMD boards. You'll see that under SAMD boards, the last option is Adafruit Circuit Playground Express. Beware that if you just type in Circuit Playground, you'll get two different things pop up. One of these is SAMD boards for the Adafruit Circuit Playground Express. The other one is for Adafruit Circuit Playground. We're going to want to select Express because that's the controller that we have. If you select the most recent version and then click Install, it will begin the install process. Now you want to plug in your Circuit Playground in Arduino. Go to Tools, Board, and then select the Circuit Playground Express from the list. If you don't see this as an option, you have to install the SAMD boards. Go back a few slides and then try again. To select the right board, we go down to Tools, Board, and then we want to make sure that under Arduino SAMD boards, we have Adafruit Circuit Playground Express selected. Make sure that if you have an Adafruit Circuit Playground, that you don't select that for the Express. Now we want to select the correct port. You're going to go to Tools, Board, Port, and select the one that has the Circuit Playground, which will either be under dev.cu.usb modem and a number if you're on Mac, or on Windows it'll be a COM port, so COM 1, 2, 3, 4, etc. In order to make sure that we have the right port selected, we want to go to Tools, Port, and then depending on whether or not you have Windows or Mac, it might look a little different. For me, I have /dev/cu.usb modem and then a number. I also have in parentheses Adafruit Circuit Playground Express. If you have an older Mac, you might not see Adafruit Circuit Express pop up, but as long as you have something that says dev or USB modem, it's probably the right port. All of the code for this course is located on GitHub. You're going to want to go to github.com/mirabellej/hackaday_sensors. You'll see a big green button that says Code. If you select that, you can select Download as zip. This will allow you to download all the files to your computer. Unzip the files and then locate them on the desktop. Open the first sketch, which is called 1_helloworld.eno. All of the sketches that we're going to be using in order to program our Circuit Playground can be found at GitHub. Specifically, go to github.com/mirabellej/HackadayU_sensors. There you'll see a big green button that says Code. If you click on this, you should be able to download the zip file and then save it wherever you like. Once it's downloaded, you should be able to open and unzip it and run any of the sketches that are in there. If you have any trouble using GitHub or downloading the zip file, you can also click on any sketch and you'll see the code. If you click on Raw, it will make it easier to copy and paste. If you're going to do this, make sure that you copy the whole sketch. If you leave out just one semicolon, it might be a problem. Open up the sketch called Hello World. If you don't have Arduino open already, it may take a second to initialize. Once it's open, you'll see the IDE. IDE stands for Integrated Development Environment, and it's where we'll be writing our Arduino code. First, you'll see an include statement that tells us that we're including the Adafruit Circuit Playground library. Then you'll see two functions, void setup and void loop. These are the two main functions of an Arduino sketch. They're a little different, however. Void setup happens at the beginning of our sketch, and anything we put in here will only run one time. So for example, we have a print statement that says serial.println, and then within parentheses and within quotes, we have our statement, started up. Then we have a short delay of 3000 microseconds, or 3 seconds. This means that when our program runs, we'll print this statement, and then we'll wait for 3 seconds. Then we'll move on to our void loop function. This function allows us to rerun code again and again and again. So here we see serial print line hello world. This message will print once per loop because it is in our loop function. Then we'll see a short delay of 250 milliseconds. Let's try uploading this to our circuit playground and see what happens. First, make sure under Tools Board that you have the Adafruit Circuit Playground Express selected. If you don't have this board, you might need to add it in Boards Manager. Next, go to Port and make sure that you have the correct port. Again, this will look a little different depending on if you're on Mac or PC. If you're on a PC, you probably will see something like COM and then a number. If you're on a Mac, you'll see something like dev/cu.usb modem and then a long number. Next, we want to upload the sketch. To do this, we can click this forward arrow. If we hover over it, it'll say upload. The sketch might take a moment to compile. If all goes well, you'll see done uploading. When it's finished, go to Tools and Serial Monitor. As you can see, we can see our statement printed out again and again and again and again. If you get an error message while uploading your sketch, try pressing the reset button between the two larger buttons twice. In this sketch, we can output text to the serial monitor. As a challenge, try changing the output to say, hello, your name, instead of hello, world. Next, try adding a second print statement, so it prints two things repeatedly. You could ask, how are you doing today? Then try changing the number in the delay from 250 to some other value to make the print statements shorter or faster. For advanced users, try writing some pseudocode or real code for a program that blinks an LED on and off each loop or plays a tone. Now let's try making some sounds. We downloaded the Adafruit Circuit Playground library, and underneath that we'll find lots of sketches that we can use. To do so, go to Examples, Adafruit Circuit Playground, Hello Circuit Playground, and Hello Speaker. This should look very similar to our Hello World sketch. We're again including the Adafruit Circuit Playground library. We're initializing our controller. We're adding a small delay for startup. And then in our loop, we're playing a tone. To play a tone on our speaker, we first say circuit playground dot play tone, and then we have two different values that are in parentheses. These values are a tone that's in hertz. In this case, it's 5,000, and then a duration, which is in milliseconds. So this is 2,000 milliseconds, which means it's 2 seconds. We're telling the circuit playground to play a tone that's 5,000 hertz for 2 seconds. Then we're adding a delay of 1 second. Because this is in loop, this will happen again and again and again and again. Make sure that you have the correct board and also port selected. Then upload your sketch. Try changing the tone to a value between 60 and 9,000 to make a higher or lower tone. You can also try changing the duration. You can try copying and pasting to create your own song. Try changing the delay to also change the moments of silence between the tones. Try changing the values for hertz and duration in playtone to make your own jingle. You can copy and paste the playtone statement. For advanced users, try combining the Hello Speaker and the Hello NeoPixel sketches to include both sound and light. For a very advanced challenge, try creating different sounds and lighting loops with functions. To solve the first challenge and make our own jingle, we're going to want to make changes to the circuitplayground.playtone function. You can see this function written as the first line of our loop statement. To make another note, let's copy and paste both the circuitplayground.playtone function and the delay. Then let's change the first value. So right now we have a value of 300 Hertz. Let's make a note that is a little higher than that last one. We can also change how long the note is played for. So right now the note is being played for a full second. Let's change this to 500 and have it play for just half a second. We can also change the delay value. During the delay, no note will be played, so this is equivalent to the amount of silence we want between notes. Let's say half of a second again. To put in a third note, we just copy and paste these two lines once again. Let's make an even higher note than last time. Let's put in 900 Hertz. Let's make this note play for 3 seconds, or 3,000 milliseconds. Then let's make a long delay of 4 seconds. Now we've made a 3-note song. If you want to add more notes, you can simply copy and paste again. Let's try uploading the sketch and see how it sounds. Learn a lot by looking at the examples of the Adafruit Circuit Playground Express library. To do so, we go up to File, Examples, and then we go down to Adafruit Circuit Playground. Here you'll see a lot of different example sketches with code that we can use. If you're new to using the Circuit Playground or to microcontroller programming, these are a great place to get started. In your spare time, have some fun looking at these example sketches and see if you can figure out what's going on. For more advanced users, I recommend looking at the microphone demos. For example, the sketch called Birthday Candles is an excellent example of interactivity with light and sound. In this sketch, we use variables to hold our notes. So instead of playing note and then entering the value directly, we create a list of notes that gets passed in when we play our note. You can see this down below. There are also variables to hold the length of the note. If you're an advanced user, try using this sketch to create your own sounds and your own lighting animations. If you're new to programming, here's a crash course in order to help you get started. Let's say we wanted to write our own new sketch that uses the Circuit Playground. First, we would want to go up to New in Arduino, and then we would open a new sketch. Sketches are always titled by the date, but you can change this later. Then we'll want to see that the first thing we want to do if we're using anything that's in the Circuit Playground library is include it. So we'll want to copy this include statement, or you can type it out if you want to. We want to put this at the beginning of our sketch. Then in Setup, we want to initialize our Circuit Playground. This is written as circuitplayground.begin. Here, begin is a function of the Circuit Playground. Then we want to put in whatever is going to go in our loop. You can copy and paste from other examples we'll do throughout the course, Or if you want to type hello world, you can type a serial print line statement. To do so, we type serial.println, beginning parentheses, open quotes, hello world, end quotes, end parentheses, and a semicolon. We end every statement with a semicolon. This is a way to let the compiler know that we're done with a command. We can also throw in a delay. Let's put in a delay of 1 second. Now when we run this program, what do you think we'll see? We'll see hello world being printed every second. We've mentioned the word function before, but what is a function? A function is just a set of commands. So in this case, we could make a separate function for printing hello world. To do so, we would write void, and then we would name our function. And then within our brackets, we would want to put in whatever our command is. So in this case, let's just say serial println hello world, and then a delay. Now if we replace this in our main loop, we can call it by saying say hello world. And then when we run it, we'll see the same result. We've used void here, but sometimes you'll see int or bool or another variable. Void means that we're not returning anything in our function, but sometimes you'll see functions, especially mathematical ones, that will return something, like a number or true or false. We'll see that later on in the course. A variable allows us to store something, either a number or a message, a character, or a value, or a true or false value, so that we can use it later in our sketches. Say, for example, that instead of saying serial.println hello world, I wanted to store hello world as a message. I could use a string variable. To do so, I would say string, would name it message, and then I would set it equal to hello world. Now, instead of hello world, I can just type message. Let's upload this and see if it works. As we can see, it still prints hello world just fine. We can also do the same to store numbers. For example, say I want to store the number 5 as my special number. Now let's say I wanted to print out my special number. I could do a serial print line, and then I could type special number. What will happen now is that when the compiler sees serial print line and then sees this variable name, it'll look to see what the value is, in this case 5. So now we'll see hello world printed over and over again, and we'll see my special number. Let's try to upload it and see what happens. We can, of course, do mathematical calculations too. So let's say that I wanted to add 2 to my special number. Now we see 7. If we wanted to, we could include this print statement as its own function. Again, we would just need to say void print special number, and then copy the serial print line statement. Then we would call it by saying print special number. And you see it works just fine. Creating functions like this is a nice way to keep our code tidy. We can also send arguments in functions. So far we've been having nothing in between the parentheses when we've been creating our functions. But here we see the Circuit Playground playtone, and it takes two arguments. First, it takes the hertz value, which is what note to play in hertz, and then it takes a duration. This can be really useful if we need to have a function that has certain values. We'll see this more in section 2. Say we wanted to store our notes as variables. We could easily do that by setting them as integer values. For the first one, let's call it note 1, and let's set it to 50. Now we can replace in our code note 1. We can do the same for the other notes, note 2 and note 3. Now whenever we want to change the note, say it's a little too low or a little too high, we can just change it at the top of our sketch instead of having to go down and find the note. This can be really useful once you start to develop longer programs. In the upcoming section, we're going to use what we've learned about the speaker of the Circuit Playground in order to trigger tones using touch. In order to do this, we're going to need to learn a technology called capacitive touch. Don't worry if that term sounds confusing. We'll go over it in detail in the next section. You might be wondering what the term capacitive means and if it's related to a capacitor. Well, it is. As a reminder, a capacitor is an electronic component that consists of two electrically conductive surfaces, also called electrodes. One is connected to the positive pole of an electrical circuit and the other is connected to ground. Between these surfaces, there's a non-conductive layer called a dielectric. The capacitor can be compared to a small battery. When sending a pulse to the capacitor, it quickly charges. When the signal goes to zero, the capacitor discharges. This creates a delay in the pulse due to the time it takes to charge and discharge the capacitor. By measuring this change in the signal, we can detect when something is being touched. And we can do some pretty incredible things with that to make reactive artworks and instruments. In 1928, Leon Theremin invented an instrument that could be controlled using this idea of capacitance. To control it, the performer positions their hands next to two metal antennas, one for frequency and one for amplitude or volume. The electric signals from the theremin are then amplified and sent out to a loudspeaker where they're made audible. Although Leon Theremin was the first to patent the invention, the theremin was actually the result of early experiments in proximity sensing by the Soviet government in the early 1920s.
Электромузыкальный инструмент терминвокс – это первый инструмент такого типа. Это песенно-голосовой инструмент. В нем управление мелодией достигается посредством влияния на электромагнитное поле около инструмента.
Now we're going to try using capacitive touch. If you've never heard of this technology, it's a little difficult to explain. But basically, on board our Circuit Playground, we have different copper pads. These copper pads can be used to sense touch. The way that this works is that each pad has an EM or an electromagnetic field. When this field is disturbed, as you can see in the left photo, it changes the reading of this field. We can use this value of change in order to trigger different effects. For a more detailed explanation of capacitive touch, feel free to look at the following two links. Cap touch is maybe better explained in action, so let's look at some examples. this piece, we see the artist using pieces of copper and foil tape and also conductive paint in order to extend the circuit. Here's another project that uses conductive paint, but this time uses it to trigger different projections that map over the painting. Here we see that the instruments are actually made out of extensions of wire. Here's another piece that powerfully combines capacitive touch with projection mapping and sound. The circuit playground has 7 built-in capacitive touch sensing pads. These are labeled as A1 through A7 on the board and correspond to the following digital pins. You should note that the digital pins are not printed on the PCB, but you can see the pinout on the next slide to see what each digital pin is. Here's the pinout map for the Adafruit Circuit Playground Express. Here you can see which pin each sensor is connected to, as well as which pin is each analog and digital pin. Open up the sketch Cap Touch Simple. This looks a bit familiar to us, but with some changes. We're still including the Adafruit Circuit Playground library, but here we're defining a Cap Touch pin as A1. We can change this number to a different pin and include any Cap Touch pin that we want to use. In our loop function, we're having a print statement that reads out the Cap Touch value of that pin. Here, Cap Pin 1 is used in place of A1, but we can just as easily say A1. Why would we want to do it this way? Well, if we want to change the Cap Touch pin, all we need to do is change the number here. This keeps our code nice and tidy. After we read the Cap Touch value, then we have a small delay. A small delay is useful to keep our Arduino from getting overwhelmed. Let's try uploading the sketch and then see what happens. If you open up Serial Monitor, you'll see different values. But if you open up Serial Plotter, you'll be able to see a plot of those values. We're reading the value from pin A1. Try putting your finger on the copper pad that says A1. What happens? We notice a spike in the values. Try removing your finger. You'll notice that it goes back to normal. How does it look if you hold your finger versus if you take it on and off? Try this yourself with your own controller. You can try different pins to compare them if you'd like. As a challenge, close the plotter and open the serial monitor. Try the same experiment. What do you notice? Try putting a piece of paper over the electrode and seeing how this changes the result. What if you use fabric? Plastic? What if we want to design using capacitive touch to trigger some kind of output? We need to set a threshold value in order to decide what value means the pad has been touched. We've done this in the sketch to Cap Touch Threshold. Open this sketch. In this sketch, Cap Touch Threshold, we have, again, an inclusion of our Adafruit Circuit Playground library. We also are still defining our Cap Touch pin. Remember, we can change this value to look at other Cap Touch pins. Then we have a definition for a threshold value. This is the minimum reading that we're counting as a touch. If you remember from our last sketch, when we were touching the pin, the value spiked. So we want to choose what is the number that's the minimum that will count as a touch. In this case, we're counting it as 500. In the loop, we're again reading the Cap Touch pin, but in this case, we're storing it as a variable called an integer. Then we're printing capacitive touch reading, and then printing the data for that reading. If the data is greater than our threshold value, then we're going to print touch. Else, we're not going to do anything. This is called an if-else statement, and it's useful for creating logic in our programs, especially if we want to use sensor data, then do something based on the sensor data. Then we have a small delay. So in this sketch, what we're doing is we're over and over again reading the Cap Touch pin's data, storing it as a variable, printing out that data, and then if the data is greater than our threshold value, we'll print touched. Let's try this and see if it works. Make sure that you have your correct board and port selected. Open up Serial Monitor. Now you'll see capacitive touch reading and then the data. What happens if you touch pin A1? Now we see a statement that says touched, and we also see the Cap Touch data. As a challenge, try having your Circuit Playground play a sound when it's being touched. To combine these two, I'm going to start by having Hello Speaker and Cap Touch Threshold open. My goal is to change the code so that I can play a tone instead of just printing touched. In order to do this, I want to find where I'm printing touched. It looks like in the code, I'm printing it after this if statement. First, I'm checking if the Cap Touch data is greater than the threshold, and then if it is, I'm printing touched. Instead of, or in addition to, printing touched, I want to play a tone. So I can copy that from my other sketch. Now I should be able to just paste it in. If I write my code like this, then if the Cap Touch data is greater than the threshold, first it will print touched, then it will play the tone. Let's give it a try. Now when I touch my Cap Touch pin, sure enough, I hear a tone. I can change the duration of the tone to play a tone for longer. Now every time I touch the Cap Touch pin, it'll play a tone for 1 second. In Serial Monitor, I'll see touched, and I'll also see it pause for 1 second while it's playing the tone. In the last sketch, we compared the Cap Touch data to the threshold by using a greater than. This is a comparison operator, and there are several of them. We can also use less than or equal to, or equal to. Or not equal to. But what, for example, if we have a value that we want to hit that's a threshold between two values? We could use a Boolean operator AND in order to set a specific case for our data. In this case, if the cap data is greater than 0 and it's less than the threshold, then we print touch. To do this, we have two ampersands. What if we only wanted to print touch if it was one value or another value? We could use the OR Boolean operator. Here's a reference of some comparison operators. You can also find a really thorough reference on the Arduino website. The built-in capacitive pads on the Circuit Playground Express are neat, but they're especially neat because we can extend them. We can use Alligator clips, wire, thread, paint, and other conductive materials to extend our capacitive touch and build other circuits. Capacitive touch or capacitive sensing allows us to detect and measure anything that is conductive. Conductive materials include, but aren't limited to, conductive thread, fabric, paint, copper, silver, aluminum, steel, tin, graphite, and other metals, electrical wires, conductive silicones, conductive sprays, and biological structures, including fruits, veggies, plants, even us. As a challenge, try grabbing something in your house that you think might be conductive. Examples of these things are anything shown, including spoons, knives, scissors, tinfoil, fruit, veggies, tin cans. We can also use conductive paint. Conductive paint is made using conductive pigments. Usually these contain silver, copper, nickel, or carbon. There's a tutorial linked here that includes how to make your own conductive paint. You can also purchase it as a paint or paint pen, pens, or raw pigments. They can be used to create conductive artworks like paintings or sketches. One bad thing to conductive paint is that it's prone to breaking, and it can crack if it's bent. I highly recommend the Bare Conductive Touch Board if you're looking to play MP3s using conductive paint. Here's an example of a performance that uses conductive paint to create a connection between a performer and a wall. Conductive thread is usually made of stainless steel and comes in 2-ply or 3-ply. When you're deciding whether to use 2-ply or 3-ply, you want to think about strength and stretch. It's a bit trickier to work with than normal cotton or polyester threads, though. It frays and it also tangles. It can be sewn by hand, or you can use a sewing machine, and sewing hoops work great to keep it steady. It can be sealed and finished with clear nail polish, PLA, or hot glue. Conductive fabrics are another way to create wearables and extend your circuit. Woven textiles which integrate conductive materials, like threads or finishes, are a great source of conductive fabric. Conductive fabric is available in ripstop nylon, stretch, jersey, and as patterns, like the one on the right. Some fabrics with metallic threads are conductive, but it really depends. It's often sold as RFID or EM electromagnetic shielding, so keep an eye out for that. Let's go even further with capacitive touch. Try attaching an Alligator clip to the pad and then attaching your conductive object. This could be foil, knife, scissors, fruit, whatever you grabbed. Then try re-uploading the sketch. What happens when you touch your object? Alligator clips are a great solution for rapid prototyping. To use them, just attach one end to whatever your conductive material is. So in this case, I'm using a piece of copper tape in a book with the idea that people will put their thumbs on it when they're holding the book. You could also use wire or foil, whatever else you want to attach to the other end. Then you want to take the other end of the Alligator clip and attach it to your circuit playground. Note that if you're getting a false positive, meaning the monitor keeps saying touch when the pad isn't being touched, you can try raising the threshold to 1015, then re-uploading your sketch. If you're still getting false positives, try unplugging or resetting your microcontroller. You might have to do this a few times before it settles. Now we've been able to trigger a tone when we press one of the capacitive touch pads. But there are 7 pads. What would happen if we played a different tone for each of those 7 pads? Let's go even further and use our Alligator clips to extend the capacitive touch pads. You can add anything that's conductive to the end. That includes metals, biological structures, fruit, plants, you name it. Give it a try, see if it works. Open the sketch to CapTouch instrument. What if we wanted to read the CapTouch value for all of the CapTouch pads? Well, we could create several if-else statements, one for each pad.
Okay, so I have to copy this, and then I have to change this to be another pin, and then I have to copy this, and then I have to change this to be the copy it. Okay, then I have to make this 2, this one 2, this one 2, and then I can change this.
But that's a lot of code. Maybe there's an easier way to do this. Well, there is. Open up the sketch to CapTouch instrument. Here you'll see something called a switch case statement. This is an excellent solution if you have lots of if statements and lots of inputs and you want to do different things for them. In this case, what we're doing is we're checking what the value is of each pad, and then if it's over our threshold, we're having it do something. And we're calling that doing something take action. So first we have an array to store all of our pads. You'll see the numbers here look a little different. This is because, as we explained earlier, there are several digital and analog pins on the circuit playground and they overlap. Then we have a variable to store the number of pads. We'll be using this later on in the sketch. In our void take action, we're doing a different thing depending on which pad we've selected. So for whatever pad has been activated, we're activating a case. So say I touch pin number A4 or D3. What will happen? First it'll print touched D3/A4. Then it'll play a tone. Then we see something new, which is break. In a switch case statement, we have to break out of the statement. So every case ends with break. Then we see the following for each of the different cases. This allows us to do something different each time we press a different CapTouch pad. You'll also see at the bottom that we have a default case, which should never happen, but it's nice to have just in case. Then we see something called Boolean. Booleans are a value that's either true or false. In this case, we're checking, is the CapTouch read greater than the threshold for a specific pad? If it is, we're returning true, and else we're returning false. In our loop, we see a for loop. A for loop is another way to do something several times without writing a lot of code. Formatting for a for loop looks like this. We start with the word for, and then we have an open parentheses. Then we have int, usually I equals 0, which means that we're starting our start value at 0. Then we have a semicolon, and then we have a limiting value. So in this case, if I is less than 10, we will do whatever is in this loop. Then we have another semicolon. Then we say what we want to do. In this case, we want to increase each time. I++. Let's use a real-world example. Let's say I have a class and I want to ask them how they're doing. I could go to each student individually and ask them, how are you doing? In this case, the code might look like serial print line, how are you doing? And then for student number 2, serial print line, how are you doing? And so on, each time waiting for a response. That would end up being 31 lines of code if I have 31 students. But we could also use a for loop. To do so, I would want to know how many students are in the class, and I would want to have a starting value. I would want to start with student number 0. In programming, we start counting at 0, so 0 is our first student. I would then set I equal to this amount. I equals 0, because we're starting counting at 0. Then I want to know how many students are in the class total. So there are 31. So I want to do this for loop for every student in the class, so that means I want to do it every time I is less than 31. Again, it's less than 31 because we're starting to count at 0. Then what do I want to do? Well, I want to go from one student to the next, which is incrementing. So we'll use I++, which is a shorthand for I+1. So we start at pad number 0, and then for the number of less than the number of pads, we go through each of the pads, and then we check to see the state of the pad. Has it been touched? If the pad has been touched, then we take action, which is this up here. After we've taken the action, we have the delay of a debounce amount. A debounce allows us to get clean data from our sensor. Often you'll have to change this amount depending on what sensor you're using, because some sensors are noisier than others. In this case, our debounce is 100. You can try changing this and see how it reacts. Let's try uploading this program and then seeing what happens. Once you've uploaded your sketch, open the serial monitor. Now try touching the pads. You should see a different message and hear a different tone for each pad you touch. Try touching each of the CapTouch pads to trigger different sounds. You can try changing the sounds in order to make your own reactive instrument. As a second challenge, try attaching the Alligator clips and various conductive objects to make your own instrument. You might try creating a sculpture using foil, wire, or other materials. Get creative. If you're having trouble getting a clean detection of a touch, you might be getting something called a false positive. A false positive is when you're getting a response that says that the sensor's been touched when it actually hasn't. This usually happens when your threshold isn't correct. To calibrate it correctly, what we need to do is we need to look at the data from the CapTouch sensor, and we need to see what a reasonable threshold might be. So you'll want to check the difference between when there's no touch and when there is a touch. And based on that value, then you can set your threshold. Once the value has gone beyond that threshold, then we know that it's a touch. You might need to play around with setting up your Alligator clips and also whatever you're attaching to them a few times to make sure that you have a correct threshold. If it's not actually detecting a change, then you might need to reset the controller. You might also need to try unplugging and replugging in the controller. Eventually it will calm down and you'll be able to calibrate it successfully. There are lots of ways to incorporate capacitive touch into your projects. You might look into creating wearables with custom sensors. These could be hidden, again, below a piece of plastic or other protective shielding. This may take some experimenting in order to make sure you can still sense touch underneath whatever you have on top. You might also try creating sculptures. These could have exposed electrodes like foil or wire, or again, you could try concealing them. Here we see a group of metal balls. Each is connected below the pedestal to a microcontroller that's capable of sensing touch. When each ball is touched, it plays a different sound. The sculpture might be polyphonic, meaning it plays more than one sound at a time, or monophonic, meaning it plays only one sound. Or you could make large-scale installations. In this seagrass installation at Burning Man, each LED animation is changed by a teensy that has capacitive touch pins. When someone touches the base of the sculpture, it changes the animation for the whole group. One benefit to using capacitive touch is that it doesn't have exposed hardware. You can create things like dials, knobs, and sliders without having to worry about things breaking. This can be really useful if you're creating an exhibit or an installation that's going to be under pressure or is going to be in harsh conditions like the desert. If you're an illustrator or painter, you can try using conductive paint or graphite or carbon paint in order to create your own playable walls, paintings, and sketches. You can start small and see how big you can go. We've learned a lot today. We've learned how to use the circuit playground, how to use example sketches, how to play tones using the speaker, and how to use the capacitive touch pads. Next time we'll talk about light output and how to use LEDs. See you then!